In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time.
All right, hello, lads and ladettes. Welcome, everyone. Today, we're going to be doing a roundtable, number 57, on Michelson Morley. We're going to get into what they were trying to accomplish with this experiment, and then we're going to break down how the experiment itself works, how these measurements are taken, and what the implications are. So, let's see. I feel like I'm missing something for the intro. I miss Toby doing the intros. But
right.
Without further ado, I guess we'll go ahead and just jump right into the history of it, starting with a little bit on light. So,
Oh, yeah.
So in 1887, there was an experiment that was put forward to test the velocity of Earth through the cosmos, and they say that they measured a null result, but we'll take a look at all that. But before we get into that, let's look into how they use light as a measurement. So prior to 1887, in the late 1700s to early 1800s, they were doing a lot of experiments with light, and specifically the magnetic permeability and electric permittivity factors. And they were into measuring wavelengths of light and the frequency. So it turns out when you split light into, using a diffraction grating, you can actually measure the wavelengths. So you can, take physical measurements of these things, come up with a scale for all the corresponding wavelengths and frequencies of light. And so they spent a good majority of time categorizing those based off of those properties. And we'll get into a little bit of that. So when we talk about the speed of light, when we talk about electromagnetic induction, we're talking about the speed of light, which is usually represented by C, and that's equal to lambda times frequency. So the wavelength times the frequency will give you the velocity of light, or the induction rate of light, which we'll get into as we continue. So to give a little visual representation of what these wavelengths are and how they conceptualize them, what we're looking at here is the electric field and the magnetic field, and the flux in between over the course of 1 second, which would give the frequency rate. So when you look at electromagnetic induction, it's based off of a flux of the magnetic and electric fields. So what we're looking at here with these peaks and troughs are is how fast that fluctuation is happening over the course of 1 second. So there might be, more intersection points over this length than just one. So this is just to kind of keep it simple, but that's the idea here. So we have a magnetic field and an electric field, and as one changes, the other one expands out, and then it starts to die down, then the other one comes back up. So that's what we're looking at. And you could take, physical measurements of the distances of these wavelengths to categorize them and break them all down. They're all, unique to a corresponding frequency. So when we get into the physical properties and what they were doing back then is they were shining lights through different materials, and they were measuring the fringe pattern or the diffraction pattern that was produced by the material, by the impedance. So then they started categorizing different materials by their electric permittivity and magnetic permittivity values, So when we look at the electric permittivity and the magnetic permeability, and how fast they can, how many times they can oscillate in a section, over the course of 1 second in free space, right? This would be how fast they can do that inside of a material, right? So it's going to change their oscillation rate, which produces that wavelength to frequency relationship. So when they put light in these different materials, and they measure these fringe properties. That's what they're determining. They're measuring how much electric permittivity and magnetic permeability is allowed in that material. So they're getting the maximum amount of speed that light can travel in that material. So they started categorizing, crystals, metals, all these different things based off of their fringe patterns and their relationship with the electric and magnetic permeability relationship. And it wasn't fully established yet that light was an electromagnetic property. We'll get into that as we continue on with the history. But yeah, when you get into these fringe patterns, that's what those different values could measure. So here we have patterns corresponding to the material. Here we have fringe patterns from interferometry here in the middle, where we're looking for the phase difference for the timing in which a signal is sent and when it's received, and that'll create a gap, and we can measure the distance between these gaps and establish a velocity relationship, which we'll get into as we continue. So this was, like I was saying, early 1700s, late 1800s. And when we get into the early 1800s, 1818 specifically, a man named Fresnel proposed that the density of the ether would be proportional to the refractive index of a material media. So if you guys, we're about to look at the one of the Fizeau experiments, but and he experimentally confirmed this prediction. But this is using that induction rate with those values for electric permittivity and magnetic permeability, they came up with a velocity amount, and then they started doing predictions off of that velocity amount for the C value. And then Fizeau in 1849 did his first experiment where he was trying to confirm that velocity ratio. So they had an expected amount. So what they had here was a turning cogwheel with a certain amount of teeth in it, and then it would rotate, X amount of speed per second for rotations. And over the course of 20 minutes, he sent a light beam through the turning cogwheel that would hit a mirror and reflect back. So basically, they would take about 20 minutes and just record the pulse rate as the cogwheel spun, and then they could take the ratio from that to get how fast the speed of light would have to be going to create that many pulse rates to get through those tooth gaps. So that approximation was within an order of magnitude for the speed of light. So it's pretty close, but it wasn't the exact amount or whatever, but it was pretty dang close. And then they went on a couple years later in 51, same person, Fizeau, used an interferometer. So this is like the first interferometer setup here, where he's using sunlight and a beam splitter. And a beam splitter is just a half silvered mirror that splits a coherent beam into two different directions to where it'll be recombined by another beam splitter. And then you'll see a fringe pattern produced on that when it recombines. So what he did here is they had a tube of running water flowing at a certain velocity, and they took the split beam light, and the beam of light would go with and against the motion of the water before it would be recombined over here, and there would be a fringe shift pattern. Now, they already knew through their previous experimentation of refractive indexes and all that, like I was going over how they went over the permittivity and permeability values for all material properties. This is like the same kind of concept. So they knew how much the water itself, the refractive index of water, would slow down that induction rate. Now, what they were hypothesizing, though, was that the water, being a material media, would drag the ether with it proportional to its velocity, and that would either give light a velocity boost or it would cause retardation proportional to that velocity. And what they measured here, outside of the confines of the refractive index, was the 88% proportional velocity ratio to the translational speed of the water. So how fast that water is moving through the pipe. They measured 88% of that, 44% going with and 44% going against. So showing that, the speed of light is c plus or minus v plus or minus the velocity of the moving material. Now, their hypothesis previous, back in these days, was that the ether was a static medium and that the Earth moved through it. So when we get into oh, this Aether model was falsified. Oh, there's no evidence for Aether. They were looking for Aether and they no Aether, right? So these are all in regards to measuring velocity with respect to a stationary Aether. So they're not looking for like a jar of Aether, so to speak, to detect. They're looking for a velocity component to confirm that their model is correct. So let's see. So here's a YouTube video you guys can check out later. I'm not going to play it, but this dude does a modern Fizeau experiment of the one with the cogwheel, and he gets pretty close to the C value of modern times. So that's pretty cool if you guys want to check out a modern reproduction of that. That's very, very interesting. So then we move on to 1685, and I think that's the year. 1865. And Maxwell, this is where he linked the electric and magnetic aspects of electromagnetism and came up with, light as electromagnetism. So this is velocity equals 1 over the square of epsilon naught times mu naught equals c, which is the speed of light. And these are the values. The epsilon and mu are the values for the electric permittivity and magnetic permeability in a vacuum. So earlier when I was talking about how they were, using material properties and shining lights and stuff through them to look at the diffraction patterns and whatnot and make the measurements, this is the same thing but done in a vacuum instead. So this is the lowest amount of physical impedance that's measured in a vacuum. And that's how they came up with that. And then, when they started doing these experiments and confirming that relationship and the values were correct, because that's what they were using for the baseline for the measurements for that rate, the same induction rate, which is about 300,000. Was it 300,000 kilometers a second? So that's they pretty much nailed it. Those values are measured in, so epsilon and mu are measured in henries and farads, so the electricity and magnetic permeability. So this is showing that there's, you can't have impedance without there being something physical to do the impeding. So these are the vacuum properties, like the vacuum impedance, showing that there's, something in a vacuum still, even when you remove all the material from it, there's still a baseline of impedance. And that would be, that's what I would consider material properties of the ether. So now that we've learned a little bit of the history of light and how it works and how they established these values and parameters that they were going to start to use for measurement, we can move on to the test for absolute motion. So once they started figuring out between 1851 and 1887, they figured out we can definitely measure linear velocity with this. So let's try and measure the Earth through space. So here we're going to get into the ether lads. This is Albert Michelson and Edward Morley. These two gentlemen are the ones that conducted the experiments. And we're going to go over their apparatus and their data. So here's a diagram of what the interferometer looked like. And we're going to look at a couple different diagrams. So we're going to get some different views of it so we can all look at it in its glory here. Starting from the bottom up, we'll see here that it's placed on a brick vat. And then that vat is filled with mercury. And then on top of that, there's this steel cylinder here that this concrete is balanced on. Now you'll notice that this cylinder is numbered equidistantly all the way down to 16, or 1 through 16. And basically what they're doing with that is they're able to they're able to make their measurements with respect to being aligned with true north, and then, obviously due east and west of that. And then as they're rotating the interferometer, they're taking measurements to see the minimum and maximum peak shift in the speed of light to see if it's related to, say that your hypothesis is that the Earth is a sphere that's rotating and it's traveling around the sun. Well, throughout the day and night, as the Earth's rotating, you're going to be in alignment. You're going to be parallel and perpendicular to the plane of motion that you're going through. So you're going to be getting, velocity addition essentially is the way you could look at it. So when you're in alignment with that, you expect the dimensions of the measurements to be, greater than what they would be versus when you're not in alignment with that. So that was one of the independent variables that they were manipulating there to make the measurements. So the orientation of the device with respect to the time of day would help give the best way to give a variable that you can manipulate there. So that's what they were doing with that. Then they got the concrete slab here on top of the vat. Now they use this because their original apparatus was much too sensitive to mechanical vibrations and ambient vibrations throughout the day. So what they did here is they had the mercury vat and then this concrete slab to really reduce the mechanical noise. And then on top of the concrete, here we have mounted mirrors in 4x4 sections that go all the way across, and we have a source emitter for the light, and we'll get into what they were using for the light source, but it was incandescent yellow light, and we'll get into all that. But anyway, they also had a telescope here that they could zoom in and look at the fringe shift pattern that was produced, because after the light beam gets split by the beam splitters here and hits all these mirrors and then gets recombined back at the other beam splitter, it projects the image on a canvas. And then they had a lab assistant holding basically like a yardstick essentially that had a thin wire on it, and they would drag it over the parts where the fringe shift pattern was projected, and they would mark those so that they could go back and measure them and get their distance relationship for when the beams recombine, and they can tell if they're in phase or not based off of that the fringe gap between them. So if they're in phase, there's not going to be a gap. If they are in phase, so, well, by how much? Well, it'll be proportional to the square of some velocity, right? So that's what we're going to get into. So we're going to take a look at some other pictures of replications that were built. So these ones were done by Miller after 1887. He continued the experimentation from 1905 to 1925. And he had the original MMX apparatus, but he also built several of his own that he could take down and take to different locations and do testing and stuff there. So this is one of the adjustable ones that you could take apart and recombine and all that. So this is his iteration of it. So see here, he's got a metal cross on a rotating platform on concrete beams or concrete pillars. So same situation. And then here we're looking at, this is with the shielding on so that you can control the ambient temperature and wind and all that kind of stuff. So what he had was a wooden casing with glass on it. And then in the original Michelson Morley experiment, what they had was solid wood, no glass or nothing transparent or anything like that. It was just solid, thick wood for their shielding. Anyway, here's a couple pictures of that. Here's no shielding. Here's just the frame. So over here, we got the light source, and then over here would be the telescope, it looks like. So yeah, this is just more mirrors and stuff, just basically reflecting beams and then looking at them through a telescope. So here's another iteration of one that he had. So it's all kind of the same setup. Nothing too fancy here. And here's another one with the shielding and the telescope to look through to look at the fringe patterns. Now here is a topographical view of what we're looking at when we talk about the light being split at a right angle to itself and then being recombined at some point so that they can make the measurements. So if you start off with the light source and then it hits a beam splitter, it gets split across this at a right angle to itself 16 times, and then it gets recombined where they look at that recombination through a telescope here. So this is just a top view of what we're looking at from the side here. More top view stuff, some diagrams with things labeled. So we got the mirrors, partly silvered mirrors, lenses, telescope, adjustable mirrors. Again, just a topographical view, nothing fancy. And then here's what they were looking at through the telescope when those beams would recombine. So the idea here was that you would have a single beam source and it would go through a beam splitter, and you know that the beam is in phase because it starts from the same source. So there shouldn't be any timing difference. And then it's going to get split in two different directions, hit their respective mirrors, recombine, and if they're in phase, then there's no velocity, component to be measured. And if they're out of phase, you'll be able to measure the distance between them to get a ratio to some velocity, which we're about to get into. So in what's put forward from the 1887 paper on the relative motion of the Earth and the luminiferous ether by Albert Michelson and Edward Morley, they start off by talking about the previous measurements that were done to detect Earth's motion through space. And that was, of course, Airy's failure and Arago's experiment, or to both of Arago's experiments. But primarily here, he gives commentary on Airy's failure, which is Airy failed to measure a heliocentric velocity component. So what he's saying here is that they didn't really have an explanation as to why the telescope didn't need much of a correction angle, because they did have to correct it by 0.8 arc seconds, but the predicted value was 30 arc seconds, 15 forward over the course of over 6 months of the year. And then over the latter part, they were going to have to tilt it back 6 months because you're going towards and away from that velocity, or, from what you're looking at in the sky based off of Earth's position along its orbit, assuming the correctness of heliocentrism. So that was their prediction. So they didn't measure a value anywhere close to that. So they didn't really know what to make of that. So a couple of explanations were put forward, mainly by Fizeau and Fizeau. I'm sorry, by Fresnel and Fizeau, who were basically stating that, okay, well, you know how we have this stationary ether? Let's say perhaps that in the telescope, the ether becomes mobile and it carries the light in the opposite direction of motion, and that would explain why there's no correction angle required. And that's very ad hoc and ridiculous, because it's just, it doesn't make any sense. And at the time, if people believed that light was a little corpuscle, like an actual particle, like they do now with wave particle duality with little quantized energy chunks, if you believed in that, you would have to say that when the light hits the water, it somehow accelerates, which is a violation of conservation of energy and momentum. That wouldn't be a tenable position for them to hold either. It's equally as ridiculous. So anyway, he starts off by prefacing that, that left us in a bad state. We're going to see if we can settle the matter with our interferometer. So using some equations that are very similar to what Fresnel proposed for the refractive index relationship with the speed of the water, instead of using the refractive index, they just have that the velocity squared will be proportional to the speed of light squared. So for the fringe pattern, and so what they do here is they come up with the reduced final form of this equation is 2D v squared over c squared, which looks very reminiscent to the Sagnac equation. Which the reason it looks very reminiscent is because they're actually equivalent and identical. So we'll be covering that in a future presentation when we get into Sagnac. But this is extremely important because this equation is the same equation that's used in inertial navigation systems and modern gyroscopes and whatnot to measure, angular velocity. So they absolutely nailed the math on this. They knew exactly what they were measuring and how, in that relationship with the fringe to the velocity, because if this were wrong, then the modern equations, would be different, and you would be able to see like, oh yeah, this is where they messed up. No, they didn't mess up. They accurately derived what the fringe pattern would be based off of a velocity of 30 kilometers a second. So when they did their experiment here, they ended up measuring a velocity that corresponds to 6 to 8 kilometers a second. Give me 1 second. All right. So from their actual measurements now, keep in mind, these are the only measurements that they've presented us with. And so we got, 6 days of data here, and they, redefined all the physics over this. And they say that that they actually measured a null result. Every physics textbook since this time will tell you the exact same thing about Michelson Morley. They measured a null. They tried to measure the ether, and they measured nothing. Like they always reframe it in a way that makes it look like this experiment was about testing the ether somehow, and there would be an ether drift velocity or something like that. Their hypothesis, again, was that this ether was static and the Earth moved through it, and there was going to be retardation in the arm perpendicular to the direction of motion. So if your apparatus is facing north, if one of these arms, let's say this one is facing north, these two are facing east-west. So this one's going to be north-south, east-west. Now they're predicting no displacement in the north-south, right? But when you're perpendicular to the motion around the sun in these east-west arms, you would experience that drag. You would experience that drag proportional to that velocity. That's what they were putting forward. All right. So what they measured in the east-west arms, right? We have a little diagram here. What they measured in the east-west was that there is a velocity component of 6 to 8 kilometers a second. So each one of these fringe notches here is supposed to be 6 kilometers a second. And it totals up to 5. So 0.05 of a fringe corresponds to 30 kilometers a second. They measured just over one fringe. So that's 6 to 8 kilometers a second. And their accuracy threshold was 2 kilometers a second. So they were well within their capability to make this measurement and determine if it was experimental error and whatnot. So let's see, let's read here. So at the end here, they had a distance of 11 meters with their light beam. So if you were to take all these beams and stretch them out instead of having them folded on top of each other, it would be 11 meters. And the wavelength of light they were using was yellow light at 2 times 10 to the 7th wavelengths. So they had their wavelength relationship. They had everything, what they were using measured, and they knew the wavelength. And then from that, they knew that the expected displacement should be about 0.4 fringes, which would correspond to about 30 kilometers a second. And what they measured was less than that by a 20th or to a 40th. So, 6 to 8 kilometers a second, way less than what was expected. And they go on to make some additional statements here and say, but since the displacement is proportional to the square of the velocity relative to the velocity of the Earth in the ether, is probably less than 1/6 of Earth's orbital velocity and certainly less than 1/4. So way smaller than what is needed to confirm heliocentrism. They didn't say in this paper, they don't say we measured a null, we measured 0 or anything like that. They're saying we made an incredibly small measurement that isn't what we expected. And then he goes on to say, in what precedes, only the orbital motion of Earth is considered. If it is combined with the motion of the solar system, concerning which but little is known with certainty, the results would have to be modified, and it is just possible that the resultant velocity at the time of the observation was just small enough, though the chances are against it. So they were like hypothesizing maybe that that there's like an additional velocity vector that for some reason is we're detecting that and not the correct one, right? Because they're going in like 5 different directions at different velocities with respect to different things, right? So, and he goes on to talk about the previous explanations that were given for Airy's failure and a couple of the other ones, which was basically, that the ether would become mobile inside of the apparatus, and maybe it's bouncing the light around, or, maybe that bouncing is carrying the light in the opposite direction with the same exact velocity potential, and it's canceling it out. But that doesn't work here because this isn't the same as like the water in the telescope where there might be some ambiguity with the experimental error, and you could like round that down to an actual 0. This is way more definitive. And like I said, it was outside of their margin of error. So he goes on to talk about how Stokes and Fizeau's explanation don't hold here. And then he says maybe, even Lorentz's theory also fails, which is of link contraction and time dilation, because the velocity measured here, it would actually have to be within that 2 kilometers a second, within that margin of error for them to say that they measured, an actual null. Because link contraction and time dilation are second order effects, they would be much, much smaller than what was measured here. And then on top of that, based off of relativity theory and Lorentz's ether theory, you wouldn't even be able to tell that you're measuring link contraction in your own frame. You would actually measure the null. So you wouldn't even know. It would be an imperceptible thing. You wouldn't have an actual displacement to measure. So he's saying, Michelson is saying that Lorentz's theory also fails. The ether at rest with regard to the Earth's surface, according to Lorentz, there could not have a velocity potential, and his own theory also fails. So all these static ether theories all at once simultaneously failed after this. Like there was no more, oh, maybe it's bouncing around, maybe when it enters the telescope, it accelerates. No. This was definitive for them. They were completely locked out of that paradigm from this point forward. So that's why they had to, this is why this was so significant for them. And it took until 1905 where Einstein proposed, basically he just reproposed Lorentz's theory, but removed the ether mechanism from it and said that time and space are not absolute. They actually change as a function of velocity squared over c squared. And from that, you can round this down to a zero. If you ignore this measurement and just call it a zero, you can suppose that the reason that you didn't measure the 0.05 fringes is because of link contraction and time dilation, which you wouldn't measure in your frame, right? You would actually measure zero, right? So that's what that whole thing was about, and why it was important, why it's important for the mainstream and all the textbooks since then to reinforce the idea that this was a null result and that they measured no velocity. Even though we can pull up the actual records and look at the velocity component, we can read directly here from the horse's mouth about the velocity component. We could read here about theories of link contraction and time dilation and mobile ether that bounces around and cancels out the effects. We can read all about how none of those have explanatory power over this experiment. And what is the number one theory that's put forward to give explanatory power over this experiment? It's link contraction and time dilation. So, this is why this experiment is hugely important, because of the level of fraud that had to be carried out to basically make the other ones viable. So here we'll take a quick look at the data for the measurements, because this is all gobbledygook. Nobody knows what any of this is. So when we look at it in a nice chart like this, we can then look at it in a nice graph and take a look at the measurements with respect to the standard deviation. So we have, 3 other measurements within the air margin. And this is just what they presented in the paper. Obviously they took more measurements, but this is all the ones that they tell us about. And then they redefined all of physics over that. So this was definitely within their margin of error. And then we have a commentary from Max Born saying that the air margin was within 2 kilometers a second. So they were definitely well within their experimental error margin to make these measurements and definitively falsify the fact, or falsify any claims that the Earth is in motion around the sun, because this apparatus, regardless of ether, would detect that velocity, right? All right, that's all I have for the original Michelson Morley experiment. Does anyone have any questions, comments, or concerns?
Wait, so you're saying that we live in a motion, Earth in motion through a static ether? Is that definitely true?
We live on a stationary Earth with respect to a dynamic ether, according to all experimental evidence.
Opposite of that. Okay. Well, then I'm just gonna keep saying my thing, and then you can defend your straw thing. How's that go?
Nice.
Alan, are you doing more MMX stuff after this slide, or are you switching to a different topic? Because I wanted to ask about the Shanklin guy.
No, yeah, you could definitely ask about Shanklin. So I was just gonna do Michelson Morley just for this one, and then do like Miller, like a follow up or something. But we could definitely get into it though.
I like keeping it digestible like this because there's a whole string of these that we have to go through that everyone
Right.
needs to understand. So we should probably take it slow and do the main baseline one because this is where most Globers' knowledge begins and ends, right? And they have a complete misunderstanding of what had happened, what they were looking for, and what they found. So exactly like Alan explained, they're gonna be like, okay, well they're gonna invert the model they're looking for. Like, okay, static ether, moving earth. Like, no, wrong. Don't let them do that. And then they're gonna be like, all right, well then there was no result. Like, no, wrong, measured motion. Here's the motion. Here's what he said he was measuring the motion. Here's what he thought about the motion that he measured. Right. And then you got to take them to like okay, well, what does that mean? And that's the whole part that they squeal and try to squeal out of. Well, it doesn't mean anything. And length contraction fixes it. They didn't change all the physics, et cetera, et cetera, et cetera. And this is why this one is super important. So I think that was an excellent, clear presentation, dude.
So you're saying he was trying to measure the ether?
So you're saying the
yes.
ether doesn't move.
Yeah, I agree with Shane. Keep it digestible for,
Yep.
the Globies. Good presentation, brother.
Thanks, man.
I think this is really for the homies.
It's for the homies, dude. But yeah, it was
To bring
only
it to the Globies.
it was only about 30 minutes though, so we could definitely do a little Shanky. But before we get into Shanklin, again, it was extremely important to have the speed of light be a constant velocity and not have any sort of preferred direction or different biases or minimum and maximum peaks or anything, because in astronomy, they were starting to use the speed of light as a constant. And if the speed of light on the surface of the Earth isn't measured as a constant, then you have no way to give like mutually exclusive claims for anything you see in the sky with it, right? To base it as a constant, because then you could just start saying things like, oh, well, you know what? The reason, X, Y, Z is because there's a different ether density around this planet or galaxy or nebula or whatever. And it just becomes like nonsense, right? And they've already done that with dark matter. But the way they've done it with dark matter, right, is they've done that to supplement a change in gravitational constants. They can't change the speed of light, right? Because that's like the ultimate yardstick. So it's very important for them, to walk away from this experiment with either a velocity component that matches heliocentrism or a constant speed of light. So like that's what was at stake here. Those are like the primary things there. Because otherwise you're just making assertions that anybody could override with their own theory. Does that make sense? So, for example, if you had stellar aberration, right, and you ratio that angle against 30 kilometers a second, if you angle that ratio against the speed of light and you get 30 kilometers a second, you're like, oh, wow, no way. That must mean Earth's orbital velocity. But you could only do that if the speed of light is actually measured as a constant. You know what I'm saying? So if it increases at altitude,
something to measure it with respect to, is what you're saying, right?
Yep. Because if it changes at altitude or something like that, then that invalidates the ratio. Then you can't use it as like mutually exclusive evidence. So that's why
you're saying that C isn't as good as C plus or minus V?
Saying they needed a very, very specific velocity for it to make their claims.
So you need a C plus a very specific V plus or minus or whatever.
Yes. Yes.
Interesting.
And then, so I did show a bunch of pictures from apparatuses set up by Miller, who continued the experimentation after Michelson Morley. So after this, 6 days of experiments or whatever, measurements, and they redefined all of physics, they suggested here that they should do different measurements throughout the year to see if they get any changes, based off of different stellar motions that would be where they would be, in alignment or parallel or perpendicular to, XYZ plane of motion that they're moving through the universe at. So they ended up not continuing these experiments, but like I said, another guy picked him up. His name was Dayton Miller. And then Edward Morley also helped him out as a lab assistant. So the lab assistant in this experiment, our boy Morley from the beginning here, makes a second appearance with Miller later on. But anyway, Miller kept repeating the measurements to see, what they would get throughout the year. And what he found was that there is a sidereal fluctuation and an annular fluctuation that corresponds to the position of the sun and stars throughout the year. So there will be minimum and maximum peaks of these measurements where they're measuring, the fluctuations of the speed of light throughout the day and then plotting them against sidereal time. When you do that, you get a sine wave that shows, a correlation with sidereal time being like the cause of the measurements. And then you also get one for the sun, or, positions of the sun that correspond to the equinoxes, where the speed of light will measure its slowest and fastest peaks throughout the year on those days, which is crazy. So, that was never refuted while Miller was alive. And it took until Miller died 14 years later, his former lab assistant, a guy named Robert Shanklin, who inherited all of Miller's data, basically burned all the data except for a little bit of it that he did an analysis on. And from that analysis, where he selectively chose three data sets that closely matched, where it would be like seasonal fluctuation errors and temperature and stuff. And he, did his analysis on those. And then one of those data sets was even from Miller's controlled data sets, which aren't even published for, this is evidence, right? This is from just controlled experiments. And he presented those as proof that Miller was just measuring nonsense and that the speed of light is a constant. And, that obviously is a super subpar analysis from our boy Shanklin. And actually all of Miller's work was, as he started getting into it more and more, he started doing more experiments to explicitly control for different heat variables, right? Like ambient temperature, direct heat. Is the heat from my lab assistant's body going to affect the experiment? Like he really, he really took it to a whole new level of like analyzing what thermal problems could arise. And to say that Miller didn't know about thermal problems and stuff was just insane. And then that's where you get into the more recent analysis from Robert Thomas, another Robert lad, who does a Fourier analysis on Miller's work. But apparently he threw out, and he doesn't tell you like what he considers good data or bad data, how he differentiates, but he throws out that sine wave that I was talking about earlier, and then does his analysis, and he goes, oh, you know what? This is just statistical noise. And Miller measured a noise that just happened to look like a real noise, or look like a real minimum, maximum sidereal flux. Like, dude, it's so absurd. So that's the history of Shanklin and Thomas.
I have one question. If we ignore the bad data, how can we be certain that this was a shank job on MMX if we don't have a handwritten check by Einstein himself to Shanklin?
Yeah. Yep. That age-old question.
Do you think that Shanklin felt extra safe when his master died in order to dig up his grave and desecrate his corpse? Or do you think he got handed a bunch of money and was promising some coercion before he desecrated his body and dug up his corpse or whatever?
Well, after that, he got exclusive interviews with Einstein, and he's quoted in all the physics textbooks as the guy that like debunked it.
What? You got material gains and renown all through the land, you say?
Yeah. Yeah, he became the man.
That's a crazy amount of motivation for someone to badmouth their boss's work, no matter what, even if they were an insignificant peon and nothing about it and just held the sticks while the dude did the work or whatever. As soon as he died, like no one knows that. You can just say whatever you want or whatever.
All right, so just because you have intent, motive, and evidence that this was a hit job on MMX.
That doesn't mean anything. It doesn't prove anything, obviously, even though he had intent, motive, and circumstance and evidence, but whatever.
Yeah. All right, lads. I think that about wraps it up.
Awesome presentation, man.
Thank you, sir. Any final questions? Let me check the YouTube chat.
So the Earth is definitely not in motion, and they were scrambling like crazy after that, and that's why Einstein had to invert mathematical realities to make the Earth move. That's crazy.
Yep.
It's crazy how they talk about it like it was like a speed bump. Like it was nothing. Michelson Morley, nah, it was no result. We measured nothing, no problem. Yeah, we invented gravitation by Einstein and bending and warping of space time on curved geodesics after that, but it's not like related.
It's not quite the same. Yeah. All right. Cool. Well, I'm gonna wrap us up. So let's see here. What do we got? Tomorrow is Schooling the Glovers, I think. So stay tuned for that. We'll be checking that out. Then Thursday will be Research and Reading Night. Who knows what we'll get into? But quick note on Research and Reading Night. We will be starting an hour early. So we'll be starting at 8 p.m. So stay tuned for that. And then Friday will be episode 118 of Flat Earth Fridays. Oh, and then Saturday, I'm having an open discussion on relativity, ether dynamics, and something else, some other word that fits in there, on Earth Awakenings at 10 p.m.
Nice.
Let's see. What is that event? 1 second. Oh, yeah, sorry. Ether dynamics, relativity, and interferometry. So if anyone has any questions about relativity, interferometry, and ether dynamics, I'll be going over the whole gambit over there. We're going to try and do an open discussion format. So it should be pretty interesting to see how that goes.
And what's your YouTube again?
Space_audits.
Oh. Cool.
Not even really banned. Can totally search still.
Not even super banned yet.
Well,
right.
I mean, not directly banned. Like if you search space_audits, you are all over it.
Oh, yeah. All right, cool. Let me turn off the old camera.